So in this question, we've been asked to integrate this function, which is x upon root of x plus 4 dx. So now the thing that we can do is assume this x plus 4 as t. In the case of substitution questions, first of all, we'll assume the thing which is in under root, which is in this case x plus 4 as t. If that thing doesn't work after differentiating and doing all the substitution, we'll think about something else. So now we'll just differentiate both sides with respect to x, which would give us d by dx of x plus 4 would be 1 plus dt, not plus, it would be equals, plus it would be 0 because differentiation of constant is 0, so it would be 1 equals dt over dx. And now we get dx equals dt. This is our equation, and we can just write and replace this dx with dt in this case. So it would be integration of x. So instead of x, if we substitute this x to one side, it would be t minus 4. So we can write t minus 4 instead of x here on the top. So it would be integration of t minus 4 upon root of t times dt. We assume this is t, so we can write it as root t, and instead of dx we can write dt. Now we'll just solve it further, which would be integration. We don't have to write here times dt. It would be like just like that. It would be t minus 4 upon root t can be written as t to the power of 1 by 2 dt. Now we'll just have to solve it further, which would be we'll just separate the denominators. It would be t upon root t minus 4 upon root t. Root t can be written as t to the power of 1 by 2t as well. So now it would be, if we solve it further, it would be t to the power of 1 minus 1 by 2 minus 4 times t to the power of negative 1 by 2 dt. Now if we solve it further, it would be 2 to the t to the power of 2 minus 1 over 2 minus t 4 times t to the power of negative 1 by 2 dt. Now we'll just separate the integrals to both of them, which would be integration of t to the power of 2 minus 1 is 1 by 2 dt minus integration of 4 times t to the power of negative 1 by 2 dt. Now if we use this formula, which is x to the power of n, integration of this would be x to the power of n plus 1 upon n plus 1 plus c. If we use it here, it would be something like t to the power of n, which is 1 by 2 plus 1 over 1 by 2 plus 1 minus 4 is a constant, so 4 will come out. It would be plus c1, integrating constant, we don't have to forget that. It would be 4 integration of t to the power of its integration, will directly write it here, which would be negative 1 by 2 plus 1 upon negative 1 by 2 plus 1 plus c2. This is another integrating constant, so it would look like t to the power of 3 by 2 over 3 by 2 minus 4 2 to t to the power of negative 1 by 2 plus 1 would be negative 1 plus 2 over 2, which would be 1 over 2. So it would be t to the power of 1 over 2 upon 1 over 2 plus c1 plus c2. c1 plus c2 can be written as an entire whole integrating constant, which would be any constant. So its answer would be something like 2 t to the power of 3 by 2 over 3 minus 8 t to the power of 1 by 2 plus c. Now if we come to the top and see what we have assumed as t, we have assumed x plus 4 instead of t, so we'll just have to write it there. So it would be 2 by 3 x plus 4 to the power of 3 by 2 minus 8 times x plus 4 to the power of 1 by 2 plus c. This is our final answer.